ballast space and your void space in the cargo area. Cargo area, there are ballast space. There is in the cargo area, you have void space also. You have in the cargo area. That also has to be checked because adjacent tank is the cargo tank. If the common bulkhead, if there is any crack, then what will happen? The cargo vapors will enter into the ballast tank or the void space, and then void space and ballast tank will become dangerous. So that's why it has to be monitored. You have the sampling point from ballast tank and void space also. When you take ballast, what you do that time that line is uh, line is not been used at that time because there is water inside. But when it is empty, that is the loaded passage, the that sample it takes from the ballast tank also. And void space, there is nothing in the void space. Void space, it is sample is always taken. Pump room, the sample is always taken from the pump to check the hydrocarbon content. An empty space also to be monitored, that haulage and sounding to be checked so that we know that there is no leakage. Suppose there is any leakage, the empty space, there will be some sounding of the haulage. So that's why, and plus, so it will ensure that it is empty. So external also atmosphere should be monitored for hydrocarbon and toxic gases uh, for prior doing any hot work. If you are doing any hot work, that hot work permit, it says that you'll have to check the atmosphere on the external atmosphere where you are doing the hot work. Because hot work, when you are doing, suppose you are doing hot work on the upper deck inside. So outside also atmosphere should be, there should not be hydrocarbon and toxic vapors. So that areas also to be monitored. Enclosed space, what is the problem actually? Mainly enclosed space, there can be a deficiency of oxygen. So monitor before entering enclosed space 21%, 20.8 up to it is acceptable, 8 or 9. But 20.9 around it is accepted, but it should be 21%. This this is very, very important because enclosed space can have the deficiency of the oxygen. How it can happen actually? Because of the oxidation. Suppose enclosed space is always enclosed, means there is no access. Usually people don't enter into that space. And then because of the oxidation, due to the oxidation, oxygen is consumed and there can be a deficiency of oxygen. So this that should not be any toxic vapor, and this 50% of the occupational exposure limit OEL, because all the gases has got a limit of occupational limit. It means this above that limit, if you if it exceed, if anybody get exposed to that atmosphere, it will be a health issue. So the no toxic vapors, and it should not be not more than the 50% of the occupational exposure limit. Because you have an exposure limit, short-term limit and the long-term limit. So it should not exceed. 50% of that should not be exceeded for the toxic vapor and gases. And the reading should be, as we have seen last class, yesterday, that 1% of LFL. So then it gets diluted and safe to enter. Now the accuracy of the gas detection system, because we need to know that yes, the reading you are getting from the gas detection system is correct. So if not correct, then it can go wrong because the people will enter into the space, but actually it is not safe. So the manufacturer will give a standard how to check that the calibration. It means the periodically the calibration has to be done for the portable gas detector as well as the fixed gas detector, and it is done annually. and the calibration certificate, valid calibration certificate has to be on board. And this, like, this has to be done by the internationally recognized standard as well. There are authorized workshop, they come and do this job. And portable one, we send it to them, and then they do it and send it back to the ship with the certificate, valid certificate. So they do, they check the calibrate means they bring the span gases, which is known percentage by volume. They use that, and then they check that the display is giving you the same value or not. If not same value, it means something wrong with your equipment. It has to be repaired, or it has to be adjusted accordingly. In fact, we have in academy, we have the span gases, all multi-gas detectors, oxygen analyzer. So we do show, but because of this online course, we are unable to show you. But three of you who are in whether one day I'll arrange for half an hour, you will be going to the workshop and see that. Okay. So as per the requirement of SOLAS, uh, ship built from July 2002, it's provided the continuous monitoring of the pump room atmosphere. Pump room is also a dangerous, hazardous space, and pump room also has to be continuously monitored. It means that gas detection systems, the sample has to be taken from the pump room also, and there has to be an audio visual alarm, so which will activate when the pump room that is the exceeds the preset limit, that is not more than 10% of area. 10%, once it reaches to 10 maximum 10%, it should give. It means it can give before below that also, so that you can act on it. And on deck, the alarm is this is the breach. This is accommodation, and this is the breach. This is your main mast, and here you have the flush light and the horn. So people working on day, they get this alarm, and they know. Suppose they get the sound, only sound will not help. They need to confirm. They see the flashlight, it means it is from that. So the audible and visual alarm has to be. It comes when it is the preset level, when it exceeds the pump room, and then it should give an alarm. And it's monitored throughout the loading, and regular checks also has to be done for the full or empty tanks, so that it confirms that the cargo is not entered into the designated, means it with like the it has to be the monitoring has to be done throughout the loading, so that you know that the cargo is going to the designated cargo tank. It's not entering anywhere else, because it can enter in anywhere else also. It can be the partition can be cracked, for an example, or the valve setting also is wrong and can go to the another space. So it has to be there is no leakage also. It ensure that those spaces where the cargo is not should not be there, that spaces your cargo has not gone to that space. The pump room, coffer dam, uh, then overboard discharge valve through, it means it can go to the sea through the overboard discharge valve if your overboard discharge valve is not closed and locked. Now, inert gas pressure also has to be monitored, and there are indication in the cargo tank pressure also, and maximum permissible level limit. The pressure, uh, when how do you adjust the pressure of the inert gas or the tank pressure? By adjusting the loading rate. So that loading rate you can adjust and accordingly, because inert gas you have the pressure regulator. You set the pressure regulator pressure from the cargo control room, and you can maintain the pressure of the tank and tank by discharge rate or the loading rate. You can adjust and then you can maintain the correct pressure. Suppose the pressure is increasing, loading rate you reduce so that you can pressure will drop. And suppose the pressure is low, loading rates you can increase. Then that way you can. And for the uh, pressure regulator of the inert gas system, you can adjust. It is adjustable. It is not fixed. So accordingly, you can adjust maintain the IG pressure as well as the tank pressure. Suppose the during the discharging, your tank pressure is falling. You can reduce the slightly the discharge. Uh, means the discharge capacity of the pump, so that the pressure will maintain. Pressure will come up. And the tank pressure, uh, vapor collecting piping system pressure. So it has to be also continuously monitored. There are sensors by which it is continuously monitored. And low pressure alarm also should be there. It is audio visual alarm has to be there. The low pressure, because low pressure is concerned to us. Why? Because the air can ingress into the tanks and then it will become dangerous. Atmosphere testing in non-inerted vessel, it means there are vessel can be there are cargoes which can be carried, which is suppose it's a non-inerted vessel, should be frequently checked because there is no inert gas, so the atmosphere has to be tested frequently in that. And various level means what does it means? The various level when the checks has been carried out, you should keep this thing in mind. So this is suppose this is a tank, and you check the condition at this point. You put the sample tube up to this, and you check it. After that, you put the sample tube up to this. You check it. After that, you put the sample tube end up to this, and you check the your you check your atmosphere. One point is not enough. Suppose you check only the lower level here, your gases, atmosphere may be dangerous here. So that's the reason all level you have to, usually it is 3, 4 level, it is being checked. And it has to check throughout the tank. It means no, there should not be any pocket of atmosphere which is hazardous atmosphere. So that's why always when the permit is issued, you must, the person who is actually involved or the person involved, they also should know that yes, it is been checked correctly. Because if it is not checked correctly, suppose the lower level is been checked, the this two level is not checked, then what will happen? People will enter into it. Actually, it might not be the safe atmosphere. The people will come to this area and will collapse. So that's why all the levels, it has to be monitored. Temperature, hot water washing also has been done. Why the hot water we do use for the tank washing? Because temperature is increases, washing become better. So that the cleansing what is sticking onto the surface of the bulkhead can easily come out. But the temperature should not be, it means this temperature above 60 degree. Suppose if it is above 60 degree, in that case, the gas concentration level has to be monitored. Why? Because the temperature means you are adding the heat energy. So the gas concentration, there can be a fire or explosion. That is the reason. It means the frequency of monitoring has to be increased. So number of time you'll be checking that you'll have to increase. And gas spring, this the atmosphere also testing has to be done, undertaken during the gas spring operation, uh, because during the gas spring operation, what you are doing, a large quantity of oxygen you are introducing into the tank, which is actually one side of the triangle. You have done the inerting. Why inerting is done by removing the oxygen. Now you are introducing the oxygen. So during the gas spring, it is very important to check the frequent checks of the atmosphere, because it can pass through the flammable zone. That yesterday I had drawn a diagram, that flammable zone, it can pass through the flammable zone when you are introducing large quantity of air. And if it is in the flammable zone, it become unsafe. It become dangerous. So another is oil discharge monitoring equipment that has to be. It means when you are deballasting the clean ballast. Clean ballast means it is not the segregated ballast. Clean ballast has to be discharged through the ODMCS. Whereas segregated ballast, you can directly deballast. Clean ballast, as I told you already, that it means that like that tank was carrying oil before the ballast was taken. So that ballast is called clean ballast. It has to be passed through the your ODMCS equipment. It means it will monitor the oil content, how much it is total content, as well as that instantaneous discharge. That is 30 liters per minute. And there, there will be an early warning if any contaminated ballast is, for an example, it detects, it will give you an alarm. So, and the inter-tank leakages, suppose between two tanks there is a leakage, it will give you an alarm. Yes, there is some problem in that water. It means the oil level is high. It means oil has come from somewhere, because before taking the ballast, the tank has been cleaned. So early warning it gives. Emergency shutdown of the cargo pump, alarm trips, level alarm. These are the emergency shutdown. Even 98% when it reaches the tank, there will be emergency shutdown will be activated automatically. It means your manifold valve will be shut. And there is a timing, as I told you, it will not shut immediately. Then there will be such pressure to avoid that. There is a timing around 14 seconds. Within 15 seconds, it takes 14 seconds to close, and it should be tested periodically, because these will not activate. It's like emergency equipment. Emergency equipment we do test periodically. Why we do check? Because it is not been used regularly. It has been used for emergency purpose. If there is an emergency, that time it has been used. So what will happen during the, if it is not periodically been tested, then during the emergency, it will not function. You will see during the emergency, it is not functioning. That is the reason, one of the reasons, that is the main reason to test it periodically. So that at all time, you know that your equipment, emergency equipment will work. Similarly, this emergency shutdown, there is a push button. It is on the manifold, it is in the CCR, as well as it is other location also, near the pump room, outside the pump room it is there. So that you can press it and then it will shut down the system. Cargo operation will be shut down. Suppose it is discharging, your cargo pump will stop. So all this IG will stop once the emergency shutdown is activated. Then there are level trips, as I told you, 98% it will shut down. That also periodically has to be tested, so that we know that it is what function correctly. And these all are incorporated in the PMS, so that the, as per the PMS it comes. But thing is that certain things has to be checked before operation. So that before the cargo operation, certain things has to be checked. So it has to be checked as per the checklist. That you don't know that there is no fixed time for the cargo operation. One time maybe it takes 20 days voyage, another time maybe it takes 10 days voyage. It means you'll have to that interval is not fixed. But there, in that case, it will be followed by the checklist. So whenever cargo operation is there, as per the checklist, you do the test of. And apart from that, also there will be in the PMS, it will be periodical checks also. Will be. So bulk liquid cargo stream, because the cargo operation also affect your structural effect, stability effect. That also you need to know. So this is the liquid cargo. There is a free surface effect. It will cause the free surface for surface effect also. What is the free surface effect? It means when there is a list, then uh, or when there is a rolling, then the cargo from one side, high side, it will go to the low side. Once it goes to the shift to the low side, then what will happen? The GM reduces. GM is the stability parameter for us, and GM reduces. It means the stability reduces. Then sloshing load means when there is a rough sea, then what will happen? The oil will shift from one side to the other side, and it will slosh onto the your bulkhead, and that will give the structural stress will increase, so that can cause the damage to the structure also. So loading sequence is important, because loading sequence should be such your the stability, structural integrity also should intact, as well as the trim and stability should be maintained. Ballasting also. Ballasting during the, suppose this is during the loading, you are doing the deballasting. It has to match correctly as per the load indicator, so that stress level, shear force, and the bending moment should not be excessive. Trim also should not be, least should not. Similarly, when you are discharging, you are doing the ballasting. Ballasting also should be such a way to keep in mind that keep it in consideration, trim, stability, and the structural integrity remain. And then change and exchange of ballast, because we know that ballast water management, as per that, it is a mandatory requirement. You need to change the ballast unless you have the ballast water equipment, that is the treatment. So in that case, you don't have to change, you can kill those creature by that system. So there can be change and exchange of ballast. It means you go move away from the port coastal area. After that, you can exchange the ballast or change the ballast, so that those harmful creature does not go to the uh, load port, because you have taken the ballast from where? From the discharge port, and then this ballast has to be discharged, means deballast in the load port. So load port area, when you go, you don't carry that ballast. You will be changing the ballast, and means there is guideline. There is no actually strict, very strict, stringent guideline is not there, because sometime it might not be possible. That is the reason. But it says that as far as possible, away from the coastline, and depth, both is it tells both depth as well as the distance uh, from the shore. So that, because mid sea you don't have those creatures. Those creatures are near the aquatic life, is near the coast. So this, during the change of ballast, then what will happen? You'll have to do such a way so that the ship stress and bending moment, shear force, it's remain within the design parameter. Trim stability also within the design parameter, because you have already taken the ballast. After that, you are changing the ballast. It means you are deballasting and taking a new ballast, for an example. But you can do it by overflow also. Most of the ships is done by the exchange of ballast is done by the overflow. So, but in that case, the trim stability and the structural integrity has to be considered and always to be monitored. Load density, all the cargo density is not same. It means you may have received same volume, but your load density, because of the load density, your load in tank, it might not be same. It will not be same because of the density difference. If density is low and the same volume, the load will be, that is the load will be less. Whereas for density, high density cargos, same volume, it will be high. So that also to be considered for stream stability and structural integrity. So this is the free surface effect. So it is, this is the high side and this is the low side. So this is the high side, this is the low side because it has listed this. So what will happen? The liquid from this side it will go to this side. So because of that, G will shift for this, and then because of that, your GM will, the stability will. Now this when it is shifting this side, it will splash slosh onto this because this it's gets the kinetic energy momentum and it will splash onto this surface of the bulk, and that also will give you a stress and strain for the vessel. It will increase. So this one, the in details, we don't need to go for your course for the tanker advanced tanker course, but just for basic, the uh, oil will shift to this side and then the G will shift from G to G1, so GM will reduce. This is the sloshing. You can see the how much load it will be due to the sloshing. It will hit the bulkhead, and bulkhead there will be stress generation. It can, if the sloshing is, it is not designed properly, then it will be very, it can damage the structure, structural damage you can have. To reduce the sloshing, what do you do? For an example, suppose you put a bulkhead in between. It means you have this tank, and suppose the cargo tank, what is being done, we put a slosh bulkhead. Slosh bulkhead is not a oil tight bulkhead. So this is the tank, suppose for an example. So this is the cargo tank. We put a slosh bulkhead. So when it is moving from one side to the other side, the distance, if the distance is more, then what will happen? The kinetic energy will be high. So it will restrict at this point. But this bulkhead is not an watertight bulkhead, there are holes. Because we are not restricting completely the flow, we are reducing the flow so that the kinetic energy will not gain that. So that the stress level on the surface of the bulkhead is less. So this is the load during the loading and ballasting sequence should be such so that this is within the limit. This is our bending moment. This is the shear force and bending moment. It should be within the limit. This is the screen of a loadicator. And this loadicator program is locked. Nobody can change. It is approved by the classification society. Once it is approved, then it is law. And during the approval, actually, it is six different condition is been checked in this software. All the ship has got approved software. It is a mandatory. requirement. You have the booklet also, stability booklet. Calculation can be done manually, but this has to be, if something is goes wrong with this, till it get repaired, the manual books has been followed, used. So SF and bending moment, which is very important, so it should be within the design parameter, otherwise there will be structural damage. You have seen there are ships incident that ship parting because at that point the shear force and bending moment exceeds the design parameter and the ship's parts and sink. Like near the east coast of Africa, there was a vessel which broke into two parts. So the oil tanker departure and arrival preloading condition. So specific non-uniform distribution of loading. Suppose the distribution of loading is not uniform because you are carrying different cargo, different grade in different tank. Then what will happen? They will not be same density. There will be non-uniform distribution of loading. Volume also it can be different from tank to tank. Then mid-voyage condition, the tank cleaning or other operation you can have in ballast passage. And the ballast condition, it means it will differ the condition. Okay. So it will differ from mid-voyage condition. It means during the passage, you'll be having the means the tank cleaning operation because load port, before going to the load port, it should be in good condition so that the receiver accepts. So this that time also this like the shear force and bending moment can change, so it has to be monitored. Docking condition afloat. Docking condition afloat means when you have gone to the docking, but it is in afloat condition. So that time also, when you are docking the vessel, there should not be any cargo. And the ship should be in gas-free condition. It is a mandatory requirement before the tanker goes to the dry dock. Loading and unloading, like transitory conditions, it means during the loading when it is or unloading, that situation is keep on changing. That time also has to be monitored. Like single high density cargo, density is high means it is heavier than water. And once it is partial tank is partially filled, then what will happen? The load will vary. If it is partially filled, the different load will be there, and then free surface effect will be there. Cargo will slosh. That problem will also be there. All this thing has to be considered. It's not that always will be your tank will be loaded full. It can be partially filled also. So in that case, what will happen? Your bulkhead can have break with the cracks, and also weld in the steel also can get damaged. That's why after that, after discharging, it has to be inspected. So the this if it is very stiff ships means the rolling is very quickly. Stiff ships is means your GM is high. If your GM is high, then the rolling period will be very high. And once the rolling period is high, then the chances of damage is high. And during the rough sea, it happens. So this actually what happened? This our course is based on the simulator based, the liquid cargo handling course. But we don't have that simulator, but it does not matter. Uh, it means still it is okay. There is no problem. But I give actually this advanced oil tanker one exercise in simulator, it is there. But that is the cargo operation, IG operation. Actually, you do, but because of online, I'll be unable to do this for you. So cargo calculation, it is basically on the deck side. So they do the cargo calculation, but you must also know this calculation, how are they doing. So they take the tanks and the haulage. This is in the ports. So the haulage, you take the haulage and then trim correction, because from the table you can find out what is the trim correction. Accordingly, trim correction has been done or the least correction has been done. Then total all volume you get, and then the free water, that is deep and volume, it is given here, and the temperature is given, then density is, because density is given to you at 15 degrees centigrade, but the temperature here you can see 25.5 degrees centigrade, so you need to make correction, because as the temperature is high, it means the volume what you have got is high. Actual volume at 15 degree will be less. So if you multiply directly by this, then unless you do the volume correction, then it will be, you see the total volume you got for this is 220,510. After correction, it will be this. So, and then the ASTM table that gives the corrected one, the volume correction factor, and then we multiply it by that, you get the this is the volume, and then you can convert into total calculated volume this, and then you have the density at 84, and then you multiply to get the tonnage. How much is the ton? Total weight of the weight in air you can get from air to air. So these all correction factors to be used, like for the bunkering also you do use these factors. So this is what I'll do. This is in your handouts. It is there. Otherwise, I'll send it to you so that you can practice, because this is the one for your training purpose. Actually, the calculation, you can do the calculation so that whether you are getting the correct values or not. Then the wage ROV, it means when there is a trim, then what will happen? It is not, you will have an wage. So that wage calculation also you can make. The exact volume, how much it is, and after the correction, how much is the exact weight it is. So this is like weight. If you have a wage, this volume is a triangle. It is different. So you need to have calculate. You can calculate the wage of this wage volume. So that exactly how much is the volume in the tank, that you can find out. Suppose you only see the table, then what will happen? It is actually this surface, this two surface parallel. But here it is not. So this surface is here, and this surface is. Suppose it is even killed, what will happen? This two surface, and this surface will be parallel. But now it is on wedge, so you need to calculate the volume of the wedge. If you directly go to the table, it will give you a rectangular shape, but whereas it is a triangular shape. So that is the calculation is given. So loading, unloading, and the storage planning means loading and unloading. Storage planning means storage means which tank, how much quantity you keep. These are the storage, so that correctly it has been loaded. So the parameter, the shear force, and the bending moment is within the design parameter. That is the way it is done. Uh, Now you need to understand the chemical properties of the oil and physical properties of the oil. So there are uh, very important thing, the hazard what we have on board the ship of tanker, the toxicity. Toxic means it is poison, which is having health hazard, and people can collapse because of that. Explosion and flammability, because explosion, you can have explosion, that is the fire hazard, and the flammability, it means flammability means it become a flammable mixture. Health hazard you can have, like the oxygen deficiency, that is the uh, people can collapse without any notice, actually that is the very dangerous thing, because brain does not work in oxygen deficient atmosphere. There are other health hazard also. There's toxicity. Uh, then you can have the tanker. You can have reaction, chemical reaction. All this inert composition also. The inert composition, as we have seen, that the O2 content should be uh, good. O2 means inert gas system should have less than 5% O2 content. And then you have other composition also in the inert gas. So inert gas should not contaminate your cargo also. That's why you'll see product carrier, usually you'll be having the IgG. IgG is better than means the quality wise, IgG is better than the boiler flue gas, because IgG, what you burn is higher grade of oil. And electrostatic hazard, this is another hazard. Electrostatic hazard, if you means this tanker, this is another big problem. Electrostatic, because when you are using the IG, it can rub each other. There are particles and electrostatic charge can create. And once the electrostatic charge is separated, means after that, when it is created, once it is separated, then it comes close to that. Then there will be a jumping of electron, and that is the spark. So once the spark is there, that is the heat, and then oxygen, if it is a combustible mixture, and there will be an explosion. Like okay, one of the case study you will do on electrostatic hazard. Now the physical and chemical properties on board. The physical properties, so this volatility, volatility means the easily it can evaporate. There are cargoes that can easily evaporate. So the vapor pressure will increase. That will cause the vapor pressure to increase. So the volatile product, the it has got a flash point of less than 60 degrees centigrade. Like for an example, cargo, for an example, the bunker oil, what we use. What is the flash point? Minimum flash point is 60 degrees centigrade. But for the cargo, you cannot say that. That I'll not carry that cargo. It means the flash point it's less than 60 degrees centigrade. It is volatile. Means it will generate sufficient vapor so that it can get ignited. And this 60 degrees centigrade is determined by the closed cup method. There are two types of method by which the flash point can be measured. One is open cup, one is the closed cup. What is flash point? Flash point means when suppose liquid is heated. Slowly, what will happen? Once the temperature of heating is you increase, the vapor generation will increase. And at one point, what will happen? There will be sufficient vapor to generate at that temperature. That vapor can get ignited by a external source of heat. It is like this. So suppose this is a container, it is closed cup, and you have the oil here, and you apply the heat. So what will happen? Slowly, suppose it is 10 degrees centigrade for an example. There will be vapor generation. You increase the temperature slowly, and there will be a thermometer. The vapor will come through this passage, and if you bring an external source of heat, suppose this is an external source of heat, you move this way, it will not catch fire. Again, you increase the temperature. Suppose your oil is flash point is 60 degrees centigrade. Then what will happen? You increase to 40 degrees centigrade. At a, there will be vapor because it was 20 degrees centigrade. Now it is 40 degrees centigrade. Vapor will come out. And if you remove this external source of heat, it will not catch fire. Now, if you increase to 60 degrees centigrade, of oil temperature is 60 degrees centigrade, the vapor is coming out. If you move this external source of heat, it will catch fire. Understood? And that is the flash point. At that temperature, we call it the flash point of that oil. Suppose it is 30 degrees, the flash point. Then, if you increase this oil temperature to 30 degree, you bring this external source of heat to this where the vapor is escaping, it will catch fire. But it will not catch fire by its own. It is not auto ignition temperature. It is the flash point. Flash point, you need an external source of heat. So that is this is the closed cup method. You can have open cup also, but as per the standard, it says that it should be measured in closed cup method. In the true vapor pressure. True vapor pressure, why we are concerned about the vapor pressure? Because the volatility. Volatility is high, the true vapor pressure will be high at the same temperature. And true vapor pressure actually it's very difficult to measure because the atmospheric pressure is not same throughout the world. It's changing. Because at higher altitude, the pressure, atmospheric pressure is less. What we do actually, we take a globally standard pressure that 1 bar or 1.03 bar, what we take, it is not all over the world, that is not the pressure. At sea level, the pressure will be different and on higher mountain, it will be different. So it will be difficult to measure the actual true vapor pressure of the liquid. Vapor pressure, what is the vapor pressure? Like we have seen that once you increase the temperature, your pressure in the vapor generation is increased. So the vapor at one time, what will happen? If you increase the temperature, the slowly the on the surface, the bubble will be created. Bubble means it will get evaporated, vaporized, and atmospheric pressure push down that vapor to the oil surface. Once it comes back to the oil surface, it becomes liquid again. But at one point, what will happen? It will exceed the atmospheric pressure as you increase the temperature. And then it can move upward direction. It means it will move away from the surface of the liquid. And that is the vapor pressure because that will give you a pressure that is called vapor pressure. And true vapor pressure, as it is difficult to calculate, that is the reason rate vapor pressure has been calculated. It is measured. So which can be measured easily. But true vapor pressure, as I told you, that there is a variation of atmospheric pressure. That is the reason it cannot be measured accurately. Negative charge body, suppose two negative charge body means excess of electron. Positive charge body means the shortage of electron. Like for an example, electrostatic charge, what we are talking about, if two substance, it's rub each other, and one is having strong bond, one is having the weak bond. Weak bond will give the electron to the, it will shift the electron from weak, means the, from that substance to the other substance. And then what will happen? The other substance where the electron has shifted from the weak bond, that will become negatively charged. And the weak object which has given the electron to the other one, that will become positively charged. As long as they are together, nothing will happen. But as the moment it gets separated, then one is negatively charged, one is positively charged, and there can be a shifting of, there can be a spark generated. Like we see the lightning is what? It is the same. So the spark, the what we see that lights during the lightning, that is the spark. And similar charge body, suppose two bodies, they are positively charged or they both are negatively charged, then they will repel. They will not attract each other. So it will repel, and if two bodies are opposite charge, one is negative, one is positive, they will attract each other. And discharge of release of energy, that is called spark because they want to neutralize. Once they're trying to neutralize, then their energy will be flow, and that energy will cause spark. And once there is a spark, means that is a source of heat. That fire triangle, one side is heat, you are giving the source of. So three state of matter we have, the liquid state, solid, liquid, and gas. So we have three state of matter, that is the three phases we have. And the properties of the solids, it is rigid. The solid is always relatively rigid and it has got definite volume and shape. It has got volume as well as shape. And these atoms or the molecules, they are closely packed. And these are, means the solid is so closely packed so that it become not compressible. You cannot change the shape easily. So it is not compressible. So all solid what have, it has got thermal energy. So it vibrates. The atoms vibrates, but we cannot make out that vibration because it is solid, means closely packed. That is the reason it's not easily visible that it is vibrating, but it is actually vibrating because the vibration is very small because it is rigidly packed and it is very rapid. It's very fast vibration. So you won't be able to make out that in an ordinary condition. Liquid has got volume, definite volume, but it does not have shape. So shape is depend on the container. Whenever any container you put the liquid, it takes that shape. So liquid bonding is not that strong. It is weaker than the your solid. Solid is very close. So this particle can move around. That is the reason the shape it can take the shape of the your container. If you keep solid in a container, it will not change the shape. Whereas liquid will change because it's the particle it can move. And this like densities of the liquid will be close to that of solid. Solid density and the liquid density difference is not that much. But the liquid bonding means molecule can move, whereas solid cannot move. That's the reason it can take the shape of the material. Viscosity of the liquid. What is viscosity? Is resistance to flow. That is the viscosity. When the liquid is flowing, it gets a resistance depending on the like viscosity of the liquid, how much it will flow. If the viscosity is high, it will flow less. Viscosity is less, the resistance will be less. It will flow more than that distance of higher viscosity. Surface tension. What is surface tension? It's attraction between the molecules. For an example, if you put, like suppose this is a tube and you have a liquid. This liquid, if you fill this pipe with the liquid tube with the glass tube and you have a liquid, so liquid will not have the label like this. So what will happen? The liquid will have label like this because of the surface. So on the surface, there will be, it will stick onto the surface. So due to the surface tension, it will have a shape like this. So that is the attraction between the molecules of the liquid. Because of that, the liquid will become, the surface of the liquid will become like. So it is surface tension causes the water to form spherical droplets. That is the reason it becomes spherical droplets like this. The water, suppose uh, you drop the water from a height, you will see once it drops onto the surface, after that it splits and the droplets become spherical because of the surface tension. Vapor pressure, as I told you that the pressure that the solid or liquid that exert and it is equilibrium with its vapor at the given temperature. As the temperature changes, uh, the vapor pressure also is changed because vapor pressure is related to reference to the temperature. Temperature changes, vapor pressure also changes because how much, and it will one time actually what happened, as I told you that from the surface the vapor will be generated. At one time, what will happen? The number of vapor which is generated and by the atmospheric pressure, the number of vapor it's sent back to the liquid, it become equal. That is the equilibrium position. And that is the vapor pressure of at that temperature. So the boiling point, that is when vapor pressure and the atmospheric pressure become equal, that is the boiling point. It means water at atmospheric pressure. What happened at 100 degrees centigrade is the boiling point. What happened at that temperature? It is generating the vapor on the surface and that become equal to the atmospheric pressure. That generates exert the pressure and that pressure become equal to the atmospheric pressure. That is the boiling point. So what we see that at a particular temperature, suppose your atmospheric pressure is dropped. For an example, uh, you are checking the boiling point in Bharadar or Addis. For an example, we are checking it in Bharadar. Bharadar, because of the altitude, the atmospheric pressure is less. It means your vapor pressure boiling point will be less. Why? Because you don't have to go to the 100 degrees centigrade to achieve that atmospheric pressure. So the atmospheric pressure is less. The at lower vapor pressure, it will be equal to the atmospheric pressure. So the boiling point will be less. Now the gas does not have the volume or shape. It means the bonding is so weak, it can move around. That is the reason it does not have the definite volume or shape. So this unconstrained gases, it will spread out indefinitely. Once you release, it will not remain in one place. It will spread all over. And confined gases, they will take the shape of their container because it is within that container. But it has to be confined. It has to be sealed. And gas particle, they have enough energy to overcome the attraction of each other. So that's why gas can move everywhere. And it will spread. Once it spreads, the density will be very low because as it is spreading, the density will drop and it will be very low. Melting point, what is the melting point? Like solid changes to liquid. At what temperature, at atmospheric pressure, the solid will change to liquid. That is the melting point. If your pressure changes, then your melting point also will change. So melting point is the temperature at which solid become liquid form. Pure of a pure substance, it can exist in equilibrium. Equilibrium. It means that is the point. Or that is the point means what we are talking about the temperature. At that temperature, it changes the state from solid to liquid. Freezing point is opposite. Liquid changes to solid. That is the freezing point. Boiling point, similarly, the liquid will change to gas or vapor. That is at what temperature, at a particular pressure, it changes. That is the boiling point. We take the reference of atmospheric pressure. At atmospheric pressure, for an example, the boiling point of water is 100 degrees because it changes from liquid to gas. And from solid to liquid, it is 0 degree centigrade as at atmospheric pressure. Sublimation is the conversion of the substance from solid to the vapor state. What is that actually? It means you can, for an example, the uh, some substance from the solid directly it become uh, gases. Dry ice. Dry ice means solid CO2. We use for refrigeration. We use for that use uh, for sub-zero cooling. That if you keep it, will it become liquid and then become gas? No, it directly become gas. So that is the sublimation. So there is, it is like this. So for an example, this is liquid. Sorry, this is solid. This is liquid. This is gas. What will happen? Suppose it changes you move this way. From solid, it become gas. Move this way, solid become liquid, then become gas. So this is the situation here. So solid can directly become, there are solids means the substances which can directly become gases without becoming liquid. Then evaporation, it is a process of a liquid changes to gaseous state below its boiling point. For an example, if you keep uh, water in a container in your home, you see after some time the level is reducing. Is the temperature, atmospheric temperature is 100 degrees centigrade? No. So it gets evaporated. It gets evaporated, it is a property. It gets evaporated at below the boiling point. And after some time, you'll see it has become dry because the moisture means the air absorb that moisture and then it gets evaporated and then at its below its boiling point. Cohesion and adhesion. So this is intermolecular attraction force, and this is between the molecules. There is a force that is the force it is talking about. So, for an example, like the molecule of water droplets held together by cohesive forces. It means all the molecule of water, it's together, it stays because of the cohesive forces. And these strong cohesive forces at surface constitute surface tension. That is the reason because they have the attraction each other, it becomes sphere, the droplets. So when the attraction force, unlike the molecule, which is strong, that is called adhesive forces. The adhesive forces between water molecule and wall of a glass tube are stronger than cohesive forces. That is the reason what I had shown you that water, that glass tube is having water, that surface, top surface will not be parallel, it is horizontal. There will be a curve because the addition of glass and water is higher than the cohesion forces. Cohesion force is between the water molecules, which is less than the addition forces. Hydrostatic pressure, so the liquid, it gives pressure, exert a pressure at any given point within the fluid within the fluid that by gravity, it means if there is a water column, there will be a hydrostatic pressure. So the hydrostatic pressure will be, it will increase depending on the depth. If the depth is high, it is high and it is more, and if depth is low, it will be low. That is the weight of the liquid column. Solubility and miscibility. What is solubility? It means it can dissolve to another substance. One substance can dissolve in another substance, that is called solubility. Like for an example, we put sugar or the salt in water. Then what will happen? You mix it, it get dissolved. That is the solubility. So solid dissolves in liquid. For an example, so like what I said just now, that salt and sugar it dissolve in water, and salt and sugar is solute and water is solvent. In that case, we call it solute is sugar and salt because it dissolve in water and water becomes solvent. Now, when two substance is mixed each other to form a homogeneous solution, that is called miscibility. Miscibility, for an example, uh, like water and alcohol are miscible while oil and water are not. If you mix like those drink alcohol, they put water in it, isn't it? To dilute, then it get mixed. So that is miscible. But if oil and water is put together, they will not be miscible. They will have separate identity. They will have layer of they will not mix each other. So that is the solubility and miscibility. Now, when something is soluble in something else, the solute dissociate into ion. That is the solute means like for an example salt or sugar, and it gives physical changes take place. So no such changes occurs during the miscibility. Miscibility that does not change. The physical character does not change. And that's why sugar, if you see once it is dissolved, you actually it was solid and then become liquid. And solubility, how it can be measured? Like every substance, suppose water, you are adding sugar. So at one point, suppose you put one teaspoon of sugar and you stir it, it will get dissolved. So slowly, suppose you put another spoon, at one point it will become saturated. That water, or the amount of water will get saturated. After that, if you put the sugar and try to stir, it will not dissolve, it will get precipitated. So that is the solubility can be measured. That suppose 1 cup of water you take, this water, how much sugar it can dissolve. So once it has reached to the solute, means the saturated point, then it will not dissolve anymore. It will get precipitated at the bottom. Miscibility is absolute. So in that case, two substances are miscible or they are not. You keep adding alcohol as you want to water, it will still mix completely. So that is it means the miscibility is absolute. You keep on adding, it will keep on mixing. Diffusion, passive movement without effort. It means the molecules or the particle. So from higher to lower concentration, it gets diffused in the molecule. So there are gaps in the molecule and it get diffused into that gap. Because whether it is solid or liquid or the gas, there are gaps between even in the liquid there are gaps between the uh, molecule, and that gaps can be occupied by diffusion. So any question till now? So okay, what do we do? Oh, now it's 10 o'clock, correct? What is the time? Yeah, so take a coffee break for 20 minutes, 10:20 will restart.
أيوه السلام عليكم Ya mana? Link. Sekali kita boleh nomor nombor kamu. Masih dalam lah. Emergency lagi. Kalau kita dah lihat, undang lah.
So good afternoon, everybody. Can you hear me clear and louder? So good morning, everybody. Can you hear me clear and louder? So let us start. The next is viscosity and the saturated vapor pressure of the liquid. So the what is the saturated vapor pressure? It means, as I told you, the vapor from the surface, it gets evaporated from the liquid, and then some of the vapor is bring back to the liquid by the uh, atmospheric pressure. So once these two quantity become equal, like it is in equilibrium position. So the the molecules which is passing from the liquid to the vapor, and from the vapor to the liquid, the molecule is coming back. That is the visual, that is called the saturated vapor pressure. And this saturated vapor pressure, it increases as you increase the temperature, the saturated vapor pressure also will increase. What is viscosity? So this is the internal resistance of the flow. It means once the liquid is flowing, if you consider the liquid in a layer, between the layers there will be resistance, and that is the viscosity. So it's basically the resistance to the flow. So the diffusion pressure and miscibility, it's like when the vapor is coming out from the tank, then what will happen? The concentration will be very high. And then as it comes out, then vented out, after that it gets the surface, it means the surface of the, as the distance increases, the concentration level reduces. So that is the nature of the vapor. On the surface of the liquid, the concentration is high. As it gets evaporated and it moves to a distance, the uh, concentration level is reduced. Higher the vapor pressure and greater the gas concentration available. And it is related to the vapor pressure. Vapor pressure is high because of evaporation rate is high. So in that case, the concentration level also will be high. So during the when the hydrocarbon gases gets vented, during the loading it will get vented. During the ballasting, if you are ballasting the cargo tank, because existing gases having hydrocarbon gases, that will get displaced and it will come from the venting. During the gas spraying also, you are introducing the large quantity of gases. Gases means air into the tank to make the gas free. Existing gases that also will contain the hydrocarbon gases, which is coming out from the vent. During the what is purging? Purging is like, suppose we want to reduce the uh, oxygen content, then we introduce the inert gas for purging. We introduce the inert gas, and then existing oxygen content, it gets displaced and the oxygen level is reduced. It gets purged. Even hydrocarbon gases also will be purged. So once it's vent, it's come out from the vent, and then immediately start what it does. It is the hydrocarbon gases. It comes out from the tank and then it mixed with the atmosphere. Atmosphere is containing the air, and the concentration will reduce. And once the concentration is reduced, and at a certain distance, what will happen? The it will concentration will be less than LEL or the LFL, and at that point it will not get ignited. That's why when it is uh, coming out from the coming out from the vent, it will not get ignited because it is designed such a way so that it passes below the LFL. Once it is below the LFL, it will not get ignited because it has got a flammable range. Within that range, that LFL and HFL, it will get ignited. The structure of the atom and the molecule, like smallest in indivisible particle of matter that can be independent is existing. The uh, that is called atom, and proton, which is located at the center, that is the nucleus, that is the of an atom. It is called proton, and each atom at least have one proton, and proton is positively charged, and is approximately 1 atomic mass, because that is the mass of the electron is having very less mass. So element will differ from each other depending on the number of protons they have. Like for an example, hydrogen has got one, helium has got two proton. So the property changes. Neutron, which is also located in the atomic nucleus, that is the nucleus. So this is the proton. Also, it is at the center and the nucleus, and similarly, the neutron also in the nucleus, except in hydrogen. So hydrogen, because hydrogen does not have any neutron. So this is a mass which is over 1 mu. So this like the neutron is made up of proton and electron like particle. Electron, those are the very small and very less mass. It's outside the nucleus. It's moving around the in the orbit, like our solar system. So they move at speed of a light, near to the light, and it's a very high speed they move. And this electron occupies the orbital, means it is moving at the orbit. And the charge on the electrode is negatively charged, and the mass is negligible. We consider it is negligible. We don't consider the mass of electron. And like you can see, 1800 electrons is equal to mass of one proton. So that is the reason we don't consider it is negligible. Nucleus, it is uh, molecules. It is the compound which is elements, definite and fixed ratios, and atoms are held together. Like the atoms are held together to make a nucleus, the molecules, and they have the bond. There are chemical means three types of chemical bonds you have, because they have to have bond each other so that they stay together. So this there are these bonds, covalent bond and etc. So those bonds, it's keeping the atoms together. So electrostatic charge is like as I told you, when the two substance rub each other, then they transfer the electron from the weak bond to the strong bond, and then they get uh, different charge they have. Like this is the electrostatic charges. For an example, metal rod surrounded, it is suspended with a rope, and piece of metal falling through the tank space. It means if it is unearthed, then the electrostatic charge will not be released, so it will be accumulated. We call it accumulator of the electron or the electrostatic charge. So unearthed conductor within the tank can acquire high potential, and then it can generate the spark when there will be chances of, when suppose you are sounding rod, you are suspended, and when you are removing it, that time it will touch on the uh, sounding pipe, and that time there will be a spark, because the it is unearthed, so the charges will be accumulated, charges will be transferred, because it has entered into the tank, and it has touched the liquid, they rub each other, and the liquid will give the charge to the your uh, sounding rod, and when you are removing that rod, it touches the uh, sounding pipe, that is the metal, and then it will get discharged through that, and there will be a spark, and it can have an explosion. It will get discharged, and there will be, and if there is a flammable hydrocarbon mixture, and it will get ignited. That's why it should be art when on tanker sounding pipes and all what we are tapes and all what we are putting, it is art. It has to be art. Sometimes you take the sample of the cargo, you put a container with the rope, and that is, if it is not art, then this can happen. So the because of the amount of charge separation, it means it will get discharged once it gets a touch in the metal, which is art, and then it will get discharged. So that is the way it get a discharge, and then it get neutralized, but it will cause the spark, which can be dangerous. And what happened, like like the voltage between the separated charges, suppose it is substantial, because once the charges are separated, there will be a voltage created between the two substances. And if it is substantial, then what will happen? There will be a breakdown voltage in the atmosphere, and then it will uh, spark will be created because the electron will jump from one to another. So to prevent these electrostatic charges, what we do, it can means during the loading also the electrostatic charges created, as well as because it rubs, the oil is rubbing through the pipeline and the pipe metal surfaces, as well as the IG when it is introducing into the tanks, also electrostatic charges can be created. As well as when you are doing the tank cleaning, that time also electrostatic charges will be created, which is a source of heat. So how do you prevent these charges? So there has to be some precautions. The pipe work electrically bonded. If you see the means on board the tanker, you have the cargo pipe. They are arched. It means it will be like this. So this is the pipe. You have the flange. In the flange, you will be having gasket, which is insulating material. So what we have, there is a bonding here. There is a plate which is screwed here. So the electrical continuity will be there. So that the accumulation of electrostatic charges should not be there. That's why when you do any maintenance, make sure this band is put back. Otherwise, suppose some maintenance is done here, you remove this, it's not put, then the electrical continuity is lost. Once electrical continuity is lost, what will happen? The electrostatic charges will not be discharged. So it will get accumulated. And at one point, there is a breakdown voltage, there will be a spark, and there will be an explosion. So, and this pipe is finally, it is electrically bonded. Electrically, it is continuous, electrically continuity should be there, and it get discharged through the hull. And the hoses also, when you connect the hoses, this hose are special type of hose. Those hose has got the electrical, that is the wire internally, so that that electrical continuity is there. So this hydrocarbon molecule, they are different type. It can be a light, it can be heavy. It will depend on the number of carbon atoms is in the molecule. Suppose it is heavy, then what will happen? These hydrocarbon gases, it will be at the bottom. It can be light, then it will move upward direction, the hydrocarbon vapors. And the boiling point, it compounds, it's ranging minus 162 degrees centigrade, that is the methane. Methane boiling point is minus 162 degrees centigrade. This is a gas form, like gas carrier, they carry methane. at if it is fully refrigerated, it will be less than this temperature has to be maintained, because at that point it will get vaporized. And it can be 140 40 degrees centigrade. Like crude oil will have all kind of mixture. It will have methane, it will have diesel, it will have petrol, all this mixture, and they have different boiling point. And it can range from minus 162 degrees centigrade to 140 degree centigrade. And composition of petroleum depends on the source. What does it mean? It means from where you are sourcing the crude oil. That depends. Like suppose it is West Africa has got oil. If it is Saudi Arabia, it is other Gulf countries. If it is a Mexican Gulf of Mexico, so they will vary because we cannot control that, because it depends upon the geographical location. It comes with some composition, and then refinery also, how it is refined, that will depend. The composition will be according. So it is always on depend on the source, because all crude oil all over the world will not have same composition. Some crude oil they have a higher sulfur, some crude oil is lower sulfur. It depends upon the location. Crude oil, which is mixture of range of many thousands of different compositions of product, it mixed with that. So crude oil, it's mixture of hydrocarbons. It will range from gases to the solid, liquid, all it mixed with. And crude oil is a split, how it is splitted into fraction in oil refinery. We call it distillation. What is distillation? This crude oil is having all this uh, product together, their boiling point is different. So at different boiling point, they have different, means the different, uh, so they have different, like for petrol, it will be one boiling point. For diesel, there will be another boiling point. So they have naphtha, they will have on another boiling point. So in the distillation column, there are different temperature area, and it has been extracted accordingly. Suppose naphtha, its boiling point is such so that from there, if it is extracted, you will get naphtha like that. Diesel, petrol, kerosene, all have different boiling point. And that is called, we do it by the fractional distillation method. So this is the another slide, another PPTs, that is the manage and supervision of the personnel with cargo related responsibilities. So in this case, the cargo operation chief officer or the mate or the chief mate, we call it. So attend to all cargo and ballast related operation. So to direct the operation at the beginning and end of the work. So he is the in charge. And before and after the beginning and deballasting operation, rough weather situation, sea condition, during tank cleaning, and all other major steps of the operation, he is the in charge. He is responsible for that. So, and captain, he verifies. Uh, and he supervise what he is doing. He is doing in the correct way or not. So one thing, the chief officer, he must arrange the deck crew. So beginning and end of the cargo work, all officers and deck rating are available and positioned at the site in principle. It means uh, the adequate manpower should be there. Not only adequate manpower is the number of manpower, but adequate as well as competent person should be there. The work planning should be such so that at the beginning and end of the work, where actually most important means once the beginning, you need to check many things because the cargo is going to the particular cargo tank which you are filling, or it is going somewhere else. If there is any leakage, there is any cargo pipeline is okay or not, hose is okay or not, flange connection, hose connection is okay or not. If there is any leakage from the hose, that is the chances are bright, high, so it has to be rectified before starting. Then only it can be started. Then end of the cargo also, that time there will be blow through. There are a lot of work to be done. There has to be sounding, frequent sounding, beginning also frequent sounding has to be taken. So the manpower, all the officers and take rating should be available. And adequate manpower as well as the competent people should be there in the, they should be involved into that. I mean, always the competent people and the chief officer should plan such a way so that the people involved are competent for their assigned duties. Beginning of the operation, number of officers present in the CCR, that is the nautical officer, deck officers, in the CCR and monitoring the operation more than one. It means there should be close monitoring. You need more people so that if anything goes wrong, you can take necessary action immediately. And during cargo operation, what do you do? At least one officer and two deck rating, including the watchkeeper in port, must be duty for the cargo work. One of them must be placed near the manifold. That is called manifold watch. Manifold watch, you cannot keep the manifold unmanned. So manifold watch has to be there. Sufficient crew should be there, available at the manifold at all times. Because manifold is you are connecting the hose. That is the most and all emergency stop. Anything that is the manifold has to be manned. And also when you are loading and discharging, then what will happen? The draft will change. And because of that, what will happen to the mooring rope? The tension will change and it has to be, mooring has to be attended. Second and third officer, what they do, they are cargo watch officer in two shifts. That's why they do 6 on 6 off. And the chief officer must give adequate instruction to the officer on duty. So, so that he gives clear order, information, and instruction what is to be done. All this cargo planning has to be discussed. Toolbox meeting has to be done, and he gives the adequate instruction so that they know what is going on, what is to be done. Otherwise, if they don't know, then how they will monitor, how they will keep the watch. And if any problem, that also has to be told to the duty officer so that he knows there is limitation. Any problem is, what does it mean? Limitation. That limitation should be known. And this instruction should be effectively passed and monitored for completion. And it should be noted down for confirmation. Like many important things, it is written down in the whiteboard so that everybody, any watchkeeper, they can see it. So which valves are open, which valves are closed, which valve should not be open. All these notes are given in the whiteboard in the CCR. so that if somebody forgets, he can see it and he can remediate it, that he will not make mistake. The duty officer should make the whiteboard. That's what I was talking about. Whiteboard provided to verify and confirm such instruction execution. So it has to be executed from correctly. And this, and you have the notebook, everything is written, what is the to be done, what is been some line is said, which tank is it filling up, and how much to be taken, when to stop. All these details instruction is there, and it is clearly instruction is there, there is no ambiguity. Decorating, so they are on duty or during the cargo operation, they do 2 or 3 shifts. It depends upon the importance as well as availability. So depend on that, they do 2 or 3 shifts. The watchkeeping in port in 2 or 3 shifts must be maintained at all times. But assigned watchkeeper in port, what he should do also participate and attend the cargo operation. They are the watchkeeper as well as they should attend and participate the cargo operation, because the chief officer must plan such a way they will be provided with some duties and it has to be attended. Chief officer also ensures sufficient personnel are available to safety conduct. Like for an example, during the cargo operation, the top four means the captain, chief engineer, chief officer, second engineer. So they 4 of them cannot go together. So they'll have to, 2 of them has to be there. Usually in tanker, nobody, means at least 2 of them has to be there. On engine side, 1 of them, and deck side, 1 of them. Either captain or chief officer, and engine side, either chief engineer and second engineer. And the sufficient personnel should be available at all times. Suppose there is any safety related issue, you need manpower. If there is no sufficient manpower, then how will you handle that situation? So that is the reason the uh, during the cargo oil transfer, sufficient, not everybody cannot go at the same time. What about the chief engineer? Chief engineer also arrange the engineers and the rating. So during cargo transfer operation, chief engineer have an engineer and crew member who will be well familiar with the cargo handling equipment. Because if any equipment failure happens, the chief engineer has to arrange for attending that issues. And the machinery of the vessel stay on board in case of any breakdown or trouble, it has to be rectified. So that sufficient engineers and rating has to, engine rating also has to be there. So this operation, following operation, at least following operation, engineers to monitor machinery and take necessary measures. What is that? That is the start and stop of pipe. And during the discharging, you need IG as well as cargo pump. So the engineers involved is more. During loading, engineers involved is there, but not that. So the start and stop of the IG, it takes time starting and stopping, and start and stop of the cargo pump located in the engine. Then once you start, after that it is controlled by the chief mate. He will control the IG pressure and all, everything he will be controlling. But he cannot control the O2 content. O2 content has to be controlled by the uh, engineers. So chief engineer will ensure that the O2 content is correctly. When he starts, it takes some time to stabilize. After that, it gets stabilized and it maintains. Start and stop of the cargo pump. Cargo pump also, once it starts, after that the chief engineer will inform that yes, it has been started. you can take over. After that, it is taken over by the chief mate. He can control the speed of the pump from the CCR, but he inform that uh, or sometime engineers control the speed. Chief mate tells that what speed he needs. So there has to be very good coordination between the uh, deck department and the engine department. And the stopping time also is it is stopped by the engineers. IG also stopped by the engineers, and there is a stopping procedure to be stopped, and pump also stopping because suppose the it is a steam driven cargo pump. It means you'll have to stop very slowly. Otherwise, what will happen? There will be differential expansion, and because of that, it can get wet, it can be seized. So it has to be. And starting time also warm up is required. Slowly, it has been started. IG also, when you stop, there are cooling down of the scrubber. So you cannot stop the scrubber from immediately. There are certain procedure it has to be followed. It cool down, then you stop the scrubber pump. Then crude oil washing related machinery operation. These are equipment, the tank washing machine. So if anything goes wrong, it has to be attended by the engineers. And there should be sufficient manpower and competent manpower. Start and stop of the deck steam and stripping pump. Because towards the end, the chief mate will use the stripping pump. In between also he uses as the tank gets empty, he transfers that tank to the another tank. Like that. So that maximum oil can be pumped out by using the main pump. So start and stop, it has to be done by the during the start and stop, it is done by the engineers. Has to be engineers give the steam, and if anything goes wrong, the engineer has to attain. Start and stop of ballast operation because the during the loading and discharging there will be simultaneously the ballast operation also, deballast operation also will be going on. So now responsible engineer, he presents during the starting and stopping of the cargo operation. And all critical steps between means in between has to also be attended by the engineer. Suppose the chief officer wants the less RPM of the cargo pump, it means it is now the steam consumption is reduced. Your boiler also has to be attended in between. So engineer has to attend that because boiler should not trip. Because when you are discharging your IG continuously, you will be needing the flue gas. So all these things, these are critical operations. So it has to be attended by the duty engineer. Junior engineer shall keep watch in two shifts. So that because second engineer become free because second engineer come for the day work and also as when required he will be attending. That's why junior engine like the deck side the third mate and the second mate they do 6 on 6 off. Junior engineer also does the two shifts. Chief engineer decide that the to regulate the engineer officer watch as per the requirement. He decides that what will be the planning for the watchkeeper. And also the personal arrangement number to be present because adequate number has to be there also. Because if you don't have adequate number, then if there is any problem, you won't be able to handle that. And number and in case of any emergency operation and the cargo equipment, machinery, crew ability, it means there should be sufficient number of persons should be there. So equipment and machinery into consideration. Suppose for an example, your loading time. Loading time you don't need the cargo pump. We don't need IG. So that time you can have less manpower. But during the discharging, IG is running, cargo pump is running. Definitely you need more manpower. So accordingly, it is considered and chief engineer plan accordingly. The personal arrangement and number be present in case of emergency. If there is any emergency, there should be sufficient manpower on board the ship. So yeah, according to the operation, it has been kept that this much number of people, number of deck people, number of engine people should be there. The chief engineer ensures sufficient personnel available for support group and organize accordingly. So during the operation, when operation are taking over by the port helper, then ship's crew give necessary details information, the characteristics and condition of the machinery equipment of the vessel. If the shore help, port help is uh, taken over, then correct information has to be given to them so that they can operate. Specific matter required attention, it has to be informed because if it is not told to them, they don't know and it can lead to a disaster. So cargo operation plan, duty system, emergency response system, communication system, all has to be it given to the port helper so that efficiently they can cope with during the with an emergency during their stay on board. It means during the emergency, if they will be staying on board, they should know all this operation so that they can handle the situation. One thing there should not be any, there is no, nothing is hidden, everything is open. Sharing of information is very very important, otherwise uh, if it is not shared properly, it can lead to a disaster. That's why always it has to be shared. Correct information has to be shared. If there is any problem with some equipment, it has to be shared so that the they know, operator knows, and the terminal knows that this equipment is uh, to be handled properly, or they will take necessary measures so that uh, the any situation, any emergency situation comes, they will be able to handle. Suppose the cargo pump rate is less, pumping rate. So they know they will deal with accordingly so that they know the pumping rate is less, or suppose the IG there is some problem. So you cannot discharge the cargo. It's as simple as that. If IG is not working, you can. That is the regulation. But it has to be informed. Or IG capacity suppose is less because of some reason. So you need to inform to the terminal that IG capacity is less, the discharging rate will be less. So understanding and knowledge of hazards and what control measures you take is associated with oil tankers. Poison, that is the toxicity is one thing, because we have poisonous gases. The those gas, hydrogen sulfide, as I told you, those are very highly poisonous hydrocarbon gases. So it can enter into your body through inhaling as well as the skin contact. Orally also it can enter. So all three possibilities to enter into the body. And poisoning, it can be acute or chronic. So it can be very acute, very dangerous, and it can be chronic also. It means it can be like if it can, some body part can be visible. The toxicity is difficult to measure because why? Uh, we cannot apply the toxicity to measure the human being. So what we do, we use the animal, rats and all. So, because we actually don't know, we know that it is what is the condition of the rat. We don't know what is the condition of the human being because we cannot apply for experiment. We cannot apply. So the studies performed that LD50 or LC50. There is two measurement we do for the toxicity. And what is this actually? When this exposed to the animals, then 50% survive. So that is, and 50%, at least 50% has to be survived. So then based on that, we decide, okay, we can apply to the human body. Apply in the sense this condition can be applied to the human body. We decide that what should be the value of the toxicity level. Flammability and explosion. So liquids cannot burn unless the flammable vapor are emitted. It means all the liquid will not burn unless it has become a flammable vapor mixture. That range what I shown you. That is and flash point, as I told you, that is the lowest temperature liquid gives of sufficient vapors from which if you introduce an external source of heat, it will get ignited. So that is the flash point. That is the lowest temperature at which it happens. This is the flammable range. What is flammable range? That is when you talk about the range, it means it has got a lower limit, it has got a upper limit. So upper and lower limit will be there. So flammable range is here. This is the flammable range. So this is the flammable red color. What you see, that is the flammable range. This is the lower limit. LEL and LFL as same as I told you, and U or HFL, HEL is same. This is upper limit. This is lower limit. Sometimes we call it lower limit and the higher. And F means the flammable limit and E means the explosive. It is same. So this within this range it will get ignited because that is the combustible mixture. Above this it will not ignite it. Below this also it will not ignite. Why below this it is not ignited? Because it is too late. It means the hydrocarbon percentage is too less compared to the oxygen content. Oxygen content is too high, it will not get ignited. And above the upper limit, it will not get ignited because it is too rich. Too rich means the hydrocarbon percentage is too. So this too rich for combustion, it will not ignite. That is above the upper limit, and combustible range mixture is in between upper limit and the lower limit, and two lane is below the lower limit. So this is the uh, flammable range or the flammable limit. In general, as a thumb rule, the 1% to 1.5% of the hydrocarbon concentration is LEL or LF. And UEL or UFL is 10 to 11.5%. That is the range. But it can vary, it will depend on the composition of the hydrocarbon mixture. It can vary, usually it is within that range. So this hydrocarbon gas might not be evenly distributed within the space. It can differ from the concentration. So the percentage it can differ. So what is the rule? It means the between hydrocarbon liquids, flash point of 60% and above, the flash point of below that temperature. We differ to different category. Below is the volatile and above is non-volatile. So the flash point also will differ accordingly. Now this is the diagram. You need to understand this diagram. So this is a flammability diagram, and this diagram, like what are the operation you do? One is gas spring operation, purging and gas spring of the cargo tank. We have this side is uh, the hydrocarbon percentage, and this is oxygen percentage. So this is 21%, and this is the line, and this is upper limit, This is lower limit. And this is 21%. Now, when it is pure air, it is here. And as it moves up, it reduces the oxygen percentage. Here, this is the range. This line is called critical dilution with air. It means above this line, you see it is a tangent here. So above this line, you have the flammable range. So this is called critical dilution line. And below this line, if you see this H, this line, it is the safe line, that is the dilution with air. And above this critical line, it means critical line, if shifts, it will go to the flammable range. Now, suppose we have, and this is the oxygen percentage. And if you see, if I draw a line here, this side, can it ignite? It will not get ignited. But this side, it will get ignited if it is within this zone. If you see what is the percentage here, it will be around 11%. So if we have the atmosphere below 11% oxygen, it will not get ignited. But then why the regulation says that it should be less than 8%? Suppose 8% is. What can be the reason? Tell me. There must be some reason, isn't it? Yes, Dasame. Have you understood what I said?
It's for safety, for
See, around 11%,
tolerance.
below 11% oxygen, it will not catch fire because your flammable range is after that, isn't it? But whereas regulation says it should be below 8%, 8% and below. Why?
It's for tolerance to avoid error.
Is for?
There must be some tolerance.
Yes, that is, but why this allowance is kept? So it is correct answer. There should be a safety margin. This is the safety margin is been kept. But reason being, the instrument which is measuring, do you know it is accurately showing? We don't know, isn't it? It might sense 8% or 10.5%, but it is actually more than 11%. Then not allowed. There will be it will be a hazardous situation. So to keep that allowance that the measuring value can differ because of the error, so it is kept 8% and below. And now another thing this diagram shows, like for an example, the tank atmosphere is at F. What is the oxygen content in that case? So from here, if we draw a line, vertical line, it is here. So our oxygen content is less than 5%. Now suppose if we want to do the gas spring. When we want to do the gas spring, what do? You introduce the large quantity of air. We have seen the diagram of the IG system. The IG blower will take suction from the atmosphere and then it will supply to the tank. Now tell me, will there be any problem if you introduce the large quantity of air into the tank in this condition? You are at F and it is, for an example, this is, let us say, 4%. It is 3.5% or 4%. Now suppose we want to introduce air, fresh air into the tank. Will there be any problem? Who wants to answer? Just think and answer, because this can be a situation, and if any mistake is done, there will be an explosion. So, is it clear what I said? In this situation, atmosphere in the tank is F. At F, you have two things. One is hydrocarbon, one is oxygen, and you have the I, inert gas. Now we are concerned about the oxygen contained and the hydrocarbon gases in this diagram. Now suppose we introduce directly the oxygen, that is the 21%, that is the air you introduce, it is the 21% oxygen. So at one point it will reach to 21%, correct? Because you are introducing the air. What will happen? You have started from here. So in that case, this was the initial condition and this is the final condition, 21%. So what is happening? It is crossing the flammable range. It had happened many times. If ship staff does not understand this, it introduce the air because he knows that it is on less than 4%. We can introduce the fresh air to make it gas free. Yeah, for gas free condition, it will be 21% oxygen. So once it introduced, what will happen? Slowly, your oxygen content will increase, your hydrocarbon gases will reduce because you are introducing air and the hydrocarbon gases will be and IG will be displaced. So in that case, what will happen? It will follow this line, and the moment it comes here, from here to here, it can get ignited, and there can be an explosion. Now, how do you overcome that in that situation? That's the reason whenever the gas freeing is done, first purging is done, and then gas freeing. What is purging? In this case, you will be introducing the IG. Inert gas will be introduced at this point. We are at this point. Suppose you introduce the inert gas, what will happen? What is the existing gas? You have the inert gas, you have the O2, you have the hydrocarbon gases. Once you are introducing the inert gas, your oxygen content will reduce. Suppose the final oxygen content is here, or it is not, let us say here, it is here. So once you introduce, this is the initial condition. You are introducing the IG. Once you introduce IG, it will follow this line. It will reduce the hydrocarbon gases as well as the oxygen. Both will be reduced because you are introducing the IG. Hydrocarbon and oxygen will get purged. Once it gets purged out, then what will happen? It will, for an example, it has come to H, which is below critical dilution line. So this is the critical dilution line. You will have to bring the atmosphere of the tank below critical dilution line. Once you are at below critical dilution line, then you can introduce the oxygen 21%, the fresh air. Then the initial condition is H and final condition is 21%. So it will follow this line. Understood? So now it is safe. Now it is not crossing the flammable range. So this vessel is safe, there will not be any explosion. So it will reach to the 21%, that is the gas-free condition. And then after that, you do the enclosed space entry permit, that is the oxygen level you check, hydrocarbon level, toxic gases level, then the man entry can be. So it had happened before. Many times during the gas spring, the explosion has happened because of that reason. So the effect on the flammability of the tank when it is uh, the atmosphere, tank atmosphere during the gas spring, what should be, during the purging, what should be, and purging is always done by the your IG. You purge it and then you do the gas spring. So purging should be first and then gas spring of the cargo tank. And when the gas spring is, it will be around 2% of hydrocarbon. Then you introduce the fresh. Now, what are the source of ignition on board the ship? There are source of ignition, smoking. That's why smoking is prohibited. There is a on the front side of your accommodation. It is written no smoking. So smoking is one of the source of ignition. Hot work. If anybody is doing hot work, that is also a source of ignition. Frictional spark. That is the reason the tanker it carries non-sparkable equipment. It does not produce spark if it is rubbed together. It means it is coated. It is not with metal. Electrical spark, electrical circuit, electrical wiring, it can produce the equipment, it can produce spark. That is also a source of ignition. Chemical spark, many chemical when they react each other, they produce spark. So that is also will become a source of ignition. Static electricity, the static electricity, we know that static, what is the static electricity? That is the two substances rub each other. It can be liquid, liquid. It can be liquid, solid. It can be liquid gas. So any, it can be for gas to gas. It can be solid to gas. So then the statical electricity is produced, and once that is it is getting separated, then there will be a potential source of ignition. Auto ignition temperature, at that temperature you don't need any external source of heat. It gets ignited by itself. So the temperature should be maintained, the cargo temperature, so that it does not reach to auto ignition temperature. Once it reaches to auto ignition temperature, then there will be a spontaneous combustion. You don't need any external source. This fire triangle, the heat you don't require. Then this spontaneous combustion, it means suppose there is a fire. Once if suppose there is a fire and fire triangle is made, the heat, air and fuel. After that, once the fire catches, after that you don't need any heat because it is oxidation. It gives us the heat. It releases the heat, and that is sufficient. Then it is called spontaneous combustion. So it will keep on burning. Pyrophore, as I told you, that pyrophore is a oxidation. It happens on the structure, steel structure. Then thick glass where you see that is a pyrophore. It is not normal glass. If you want to, uh, if you want to suppose remove that rust, if you are going to chip it, and that will give means and that produces so uh, high level of heat, so it can uh, support the combustion and there can be a fire or explosion. And flammability and explosion. So high vapor pressure petroleum product. There are products there the vapor pressure is high. So if it enters into the empty gas-free tank, then what will happen? There will be rapid evolution of gas. The vaporization will be very high. And the density of the gas will form a layer. That means there will be high density vapor forms layer. At the bottom will be high, at the top will be lighter. So the oil surface on the means the tank, it means the bottom of the tank that rises with the oil surface, and that gases also move up. And reason for this gas to be expelled from the tank, when it is then it has to be expelled. So why it is been expelled from the gas from the tank during the loading? Otherwise, the pressure will increase. Unless you are using, even you are using the gas recovery system, vapor recovery system, it means it has to be removed from the tank. It is giving to the terminal, or if terminal allows, it can be vented out. But it has to be expelled from the tank, otherwise pressure will keep on increasing. Ballasting into the cargo tank, same thing. The pressure will increase, and at one point the pressure increases, it has to be expelled from the tank. Inert gas purging, when you are purging the inert gas and the inert gas is used for the purging, then it has to be expelled. This flammable vapor, that is hydrocarbon vapor. During the gas spraying, you are removing the hydrocarbon gases. It means it has to expel from the tank. These are the operation in which the gases, hydrocarbon gases, is expelled from the tank. So this gas has to disperse in the atmosphere. So this, like the danger of this gas is dispersion for the ship's accommodation, because accommodation is the living place, and the as well as the jetties, terminal and the jetties, because this gases like disperse from the ship's accommodation and the terminal jetties. And what will happen? This hydrocarbon gas displays during the loading, ballasting, gasping, and the purging, because it comes out through the vent and immediately start mixing with the atmosphere, because atmosphere is released to the atmosphere. And what will happen? Progressively the hydrocarbon concentration reduces until some distance from the vent, that uh, distance height is kept such a way so that it passes below the LFL. Once it passes below the LFL, then there will not be any concern of flammability hazard. So the ship is designed such a way so that once it's expelled, it get means the dispersion takes place, and then it become below the LFL, so that there is no it, it does not catch fire. So that is the reason, like in the vicinity of any web, there should not be any flammable zone, so that it does not have, it means the gas concentration is above LFL. It gas should be released in a place where there is no flammability there. So that otherwise what will happen, if there is a flammable zone which the concentration is above the LFL, there can be a fire, potential danger of fire and explosion. So it is released such a places where there is the gas concentration, it is not a flammable zone, where the gas concentration is above LFL. So then otherwise it will be a source of ignition for at that point, because if it is reaches to the flammable zone, or at a source where at a location where the source of ignition is there, then it can get. It is such a way it is designed, it will not get released in that area. Now the superstructure and accommodation block,
Huh?
the gas also can enter through the door, ports, and ventilation intake. Those are the danger. So that is the reason, as I told you, the accommodation system, it is uh, like accommodation ventilation system, it is
ሀያት አደባባዩ ጋር ያለው ንግድ ባንክ እዛ ጋር
ሎሚያድ ፊት
እንጠብቅሻ።
ለፊት ነው
ሎሚያድ
ወይንስ?
ፊት ለፊት ወይስ
it
የቱ
is
ጋር እንምጣ?
on recirculation. And the cargo area, it is regarded as the free of source of ignition. In the cargo area, there is no source of ignition. It is kept. The equipment, electrical equipment, it is approved type. There will not be any source of ignition. There is no smoking, no camera, no cell phone you can use. Those can be a source of ignition. Any equipment you use there, uh, it has to be approved type, and it should not generate any source of ignition in the so work area, and this is the thoroughfare. It means so that there is no danger of uh, explosion and the fire. Adjacent to the jetty, free of source of ignition. Adjacent to the jetty also it will be free of source of ignition. And work area, and it it is because it is a work area and thoroughfare area. It means you are moving around through that area. That's why there should be free of source of ignition. Adjacent vessel such as lightering ships, bunker. It means if you are doing STS, then there will be another ship. You can take bunker and the stored craft, pilot, crew transfer boats, terminal facilities, because those you are not controlling, but they should be also safe. Then your ship is safe because uh, they can be a source of ignition. Dispersion of air vapor mixture in wind speed above 5 meter per second. It means the dispersion of air and the vapor mixture, if the wind speed is 5 meter per second, then sufficiently to avoid the flammability risk because it gets dispersed and the concentration reduced and it becomes less than 5%. Uh, just one sec. Let me contact Addy's office. Addy's got disconnected.
Yeah, online, sir. Sir,
Yeah,
they are online. Sir.
they are online.
Yes.
Oh, yeah. So that if the wind speed is 5 meter per second, above 5 meter per second, and it gets the flammability risk can be avoided. High velocity wind ensure an efflux velocity of more than 30 meters per second. The high velocity wind, as I told you, it should be when it releases, it should be more than 30 meters per second. The reason I have already told you, so that if there is any fire, the flame velocity is around 22 meters per second. So by the time it reaches uh, to that towards the vent, it is already closed. Then ingestion of the petroleum, it means it can be low. Petroleum is a low oral toxicity, but when it is slow, means solid, it goes through the oral to the stomach. The acute discomfort you have, and nausea you can have, dizziness, and you can have the vomiting. So possibility there will be vomiting, and it can go into the lungs. Once it goes into the lungs, the serious consequences the human being will have, especially if the volatility is very high. And gasoline or kerosene, like for such and gasoline or the kerosene. And the skin and the eye, the petroleum product, if it goes into the eye, that also will have effect, adverse effect. And the skin, through the skin also it can enter into the body. So there are many petroleum products which is highly volatile. So that will give irritation, like itching and all. And they remove actually essential oil from the body, and then it will be leading to the dermatitis. It means the skin, it can get damaged when it is contact into the skin. Then eye also it gets irritated. It will get irritation in the eye, and heavier liquid, that is the heavier oil, it's serious skin disorder, and it can, if it is repeatedly and prolonged in contact. So you can see this is the person who was exposed and there was a contact on the eye. You can see the condition of the eye. That's why when the if cargo is dealt with, that time there should be goggles, safety goggles to be worn, so that there will not be any eye contact. The cargo will not be in contact with the direct contact with petroleum. It avoided by wearing appropriate PPE and gloves and goggles, so that there will not be direct contact with the skin and the eye and the so that, I mean, you will be protected. The this the effect of petroleum gases on human health is complication, and it may cause that eye you can see the condition. This is the eye is affected. There are symptoms of narcosis. It means the symptom will be, it will be like a person has abused the narcosis. So that will be the situation. That person will have dizziness. He will talk something else like that, and it may lead to the unconsciousness, like introduced by the narcotic drugs. Low concentration of petroleum, it gives you a headache. If you have headache, it means something is wrong. You have already eaten. It has gone into your body. An eye irritation and responsible. That person, you will see that he is unable to take the responsibility. Actually, he is not his fault. You cannot say that he is not competent. Actually, it is affected. That is the reason he is unable to take his responsibility. You must consider that. And then the dizziness, intoxication, like if a person is it's like the intoxication condition, it will give you a symptom. If it is high concentration, lead to paralysis. It means the insensitivity and death. Finally, it can loss of life also can be there. These are the health hazard which is very very important, so that we don't want anyone on board the ship should suffer. Toxicity of the petroleum gas, it will also vary depending on the what are the hydrocarbon constituents. Now there are threshold limits for each type of hydrocarbon gases or the hydrocarbon. And there is a limit. That is the threshold limit. That is the TLV, and time weighted average. That is the TWA. And it is accepted by the petroleum gas. Now TLV and TWA, how much you can expose to that condition? 8 hours per day, and total hours is 40 hours per day. So you cannot go beyond that. You can get exposed if the level is TLV and TWA. Then TLV and TWA not to be applicable to the gases containing benzene and hydrogen sulfide. Why? These two are the very high poisonous gas. So it will not be applicable to these cases. Now, human body can tolerate a concentration above TLB for short period. This is the long exposure. And this comes under the occupational health and safety. So the TLB, suppose the limit value is more than the TLB, you can expose to that condition, but for a short period of time. What is that short term exposure limit? So this is the condition. So in that case, that the exposure is maximum 4 exposure of less than 15 minutes. So you can have exposure, but less than 15 minutes and maximum 4 exposure in a 24 hours of period. And at least 60 minutes gap between two exposure, consecutive exposure. Suppose you are exposed to this condition for less than 15 minutes at 1 o'clock. So next exposure you can have at 2. So it has to be, interval should be 60 minutes. And in 24 hours, you can maximum exposure should be 4. This is short-term exposure limit. So these two conditions we need to consider and comply with. Now, there is absence of smell of gas, which is insufficient guarantee of above TLV odor. Because there are smell of the gas, if it is absent, it does not mean that it will guarantee that the absence of TLB odor. No. So that's why TLB has to be measured. Combustible gas indicator cannot be accepted to measure TLB. For TLB measurement, you have different equipment. Combustible gas detector, it gives you the hydrocarbon percentage, not TLB. So it cannot be accepted as a measure of TLB. Leaded gasoline. If you go to the petrol station, you will see some petrol is without unleaded and some is leaded. Leaded petrol gasoline is more toxic than unleaded gasoline. And if it goes into the body, then what will happen? Through the skin. So little difference between the toxicity and the of the vapor of leaded and unleaded petrol. But the toxicity is more that it absorbs through the skin. So there will be, if you think that leaded gasoline is more toxic than the unleaded, but the effect will be almost same when it goes into the body. Now the inert gas composition, what are the hazards of the inert gas? By introducing inert gas, what you have done? You have minimized the fire hazard. But have you introduced some other hazard? By inerting the compartment, once you have inerted the compartment, you have minimized the fire hazard, but you have increased the health hazard. Can a human being survive in that atmosphere? Because the oxygen percentage you have reduced, cannot survive. So one way you have done something good, another way something can go wrong. So that is the reason the IG itself also is a health hazard, because human being cannot survive into that atmosphere. The toxicity constituent of the inert gas also carry the toxic gases. What is the main hazard? Inert gas, low oxygen content, and its from the it produced from the combustion, that the boiler or the IgG. Then what will happen? That it is from the flue gas, so there will be trace of amount of various toxic gases, which is hazardous to the human being when it is exposed, like carbon monoxide. Then we have the other gases, SOx, NOx, and all will be there in the inert gas. So, what is the precaution to protect from this toxic component in the inert gas? Tank entry, gas filling of the cargo tank. There are there are certain conditions. One is the hydrocarbon concentration should be less than above means about 2% volume to 1% of element. Then it gets diluted so that it is safe to enter. Oxygen contained 21% and toxic constituent below their TLV and TWA. So you need to check the compartment as per this requirement, then it is safe to enter. Otherwise, you cannot enter. It is hazardous to enter into that compartment. So hazardous property nitrogen oxide in the flue gas you have. So nitrogen oxide is colorless gas. You cannot see. Very little smell. And at TLV at or TWA of 25 ppm. And nitrogen oxide is more toxic with a TLV value of 3 ppm, 3 ppm. So it is like it varies from gas to gas, toxic gas, which one is more dangerous to the health. Suppose some other gas at this 3 ppm might not be that dangerous. There are charts, it's clearly given which one TLV limit, what will be the TLV? That is the limit. It varies from gas to gas. Sulfur dioxide, it comes from the fuel oil. Sulfur comes from the fuel oil, whereas NOx is from the combustion. So the sulfur comes from the fuel oil. How much fuel oil is containing the sulfur, and in the uh, scuppered, it can be efficiently removed. As per the design, it removed, and as per the requirement of the solars, it should remove more than 90%. It should remove the sulfur from the scupper. Carbon monoxide, it contains it depends upon the combustion. If the combustion is complete combustion, you will not have carbon monoxide. You will have carbon dioxide. But depend on the combustion condition, you can produce carbon monoxide. Electrostatic hazard. This is another hazard you have that I have already told that two dissimilar material when it's in contact, they rub each other and charge separation occurs. It means there will be an interference. It means the weak material will give the electron to the strong material, and then there will be a charge separation. And once these two solids, or it can be two solids, a solid, a liquid, two immiscible, a liquid, and like immersible liquid means oil and water. Oil will contain crude oil, will contain water. It means there will be a layer of water and oil. So there will be a rubbing effect due to the rough sea. There will be a electrostatic charge. Then they are in contact. As long as they are in contact, there will not be any problem. But once they get separated, and then there will be a spark. And there will be a voltage differences will be created as you are moving apart, and then there will be a breakdown voltage, and with that there will be a spark, and that spark can cause a explosion. If the charges, like voltage difference between the charges of opposite sign is very small, then the spark, that energy will be less. It will not be able to support the combustion. There will not be any hazard, but it will depend how much the charge is accumulated. If the charge accumulation is high, it means the voltage difference is high, and then it can lead to hazard. When charges are widely separated, a large voltage, then potential of the difference is high, then there can be a danger. Means become an electrostatic field. And no other exist, defined material remain in contact because they get neutralized. But once you separate them, then they become that potential is created. Large voltage difference charge develop after the charge separation. Once you separate, then the voltage difference will come and the large voltage will. Once the creation of electric field, then what will happen? The charge are separated. There is a large voltage separation, voltage differential distribution, and set up the throughout, and then the neighboring spaces. So what will happen? The neighboring spaces will be electrostatic field will be created. If you see this example, you will understand the charge on the charged petroleum liquid. The oil can be charged. They are static. So the charged petroleum liquid in a tank, suppose it is entered into the tank, then what will happen? Electrostatic field will be throughout the tank. Throughout the tank, there will be an electrostatic field because the petroleum you have received is already charged. And both liquid in the Rx space will be charged. And that is the reason when you introduce a tape or you take the sample with a can, if it is not hot, then this charge will transfer to that. And then when you are removing at the top, when you are removing through the sounding pipe or the foliage, it touches the metal, there will be a spark and there will be an explosion. The charge on the water mist formed by tank. It means when you are doing the water washing, there will be water mist, and that also will be charged because that will have a rubbing action with the gases, and then that will have a static charge. So charge separation within the conductor in a electrostatic field. So uncharged conductor, when it enters into the electrostatic field, there is a potential created. And because of that potential, because the conductor is uncharged, so what will happen? It will become the same voltage the region is occupied. And that movement of the charge to the conductor, one means it will attract to the field to that conductor and it will be equal to the opposite charge. And then what will happen actually if you are introducing an uncharged object? Suppose this is the uncharged object. As it is moving down, what will happen? One side will be attracted because there is an electrostatic field, and other side will be the, suppose this will become plus and this will become minus. It means all the, because it is introduced into the electrostatic field because the tank is electrostatic field. It has made an electrostatic field because it is containing the oil which is charged. Then what will happen? This side it will be attracted. This side, because it is negative, for an example, this will become positive, and other charges will go to the other side. It will have polarization. So this opposite end will be left with opposite charges, and once this charge separation it's introduced, it means this is called induced charges, and it gets separated as long as it's present in the field, and then they can contribute to the electrostatic discharge. What will happen if this charges is high? Then what will happen? It will get discharged, and that will create a spark. So now tell me any question till now. So any question? So tell me one thing. As I told you during the tank washing, crude oil washing, there will be um, electrostatic charges. So to eliminate the explosion and the fire, that is a source of uh, heat. What will you do so that there is no fire or explosion? When you are doing the tank cleaning, uh, crude oil washing is done during the cargo operation. But after departure, you have discharged the cargo. After the discharge, you are going to the load port. You will be doing the tank washing for preparation of the tank for receiving the next cargo. Now, during the tank washing, you will be doing by the water with the same tank washing machine or the crude oil washing machine. Machine is same. Now tell me, there will be electrostatic charges. How will you deal with that? That can create an explosion in the fire. What do you think you should do so that there will not there will not be any fire or explosion? Who wants to answer? Is it clear, my question?
Yes, it is clear. Can I try?
Yeah, definitely. Tell me.
Okay, so the tank should be inerted so
Yeah,
that should be no explosion.
absolutely correct. Even during the tank washing, the tank should be inerted so that you can avoid the fire and explosion in that condition. In fact, a tanker should always be inerted, tank should be always inerted. Unless it is going for maintenance for or dry dock, then gas spring should be done. Whether it is loaded, whatever operation you are doing, it should be inerted. So let's do one thing. Let's any question from your side. So let us take the lunch break and 1:30, that 13:30, 1:30 will start again. So you take a lunch break, go for lunch, and then we'll start again.
Salam. Mic una bro. ማነሽ?
ባንክ ደረስክ?
ያው ሰፈር ውስጥ እየተርመጠመጥኩኝ ነው። አንድ ደህና ነገር የሰራውን ነገር የለም።
ምሳ እንብላ። እዩ ምሳ እንብላና
ዳጊስ
ብር ላውጣ ብላለች።
አትክፈል Aha, mami. Ya يشكر. ها يلا يسكاك انا هم تاتي ليش هنا دتلان من تسستالش انا يكايروا لا مشكلة هيدو انتنا ठीक है मैंने हमारा ना पर बस ओके ले daño le ደግሞ ትስልታለ ዋናው ፊት ለፊቱ ያንተ ነው አንድ የሚያያዝ ወረቀት ነው
አለ ሙት አድርገው ድምፅ እየተሰማ ቼክ
Yes, good afternoon. So it is where are the Addis people?
चलो
So now tomorrow is being Saturday, but you'll have a full day class because if and Sunday will be off completely. If Saturday become half day, then the course will be extended. Understood, everybody? So we can finish on Tuesday. As per the program, what I had said, it's closing on a Tuesday. Tuesday after lunch, it will close. But what about okay? Let the Addis. Yeah, where are the others? Addis office. Just call others. Yeah. Yes, Addis, where are the others? So, as I told you, those who are not there, okay, I'll speak, let this Addis people come. So let us start with, so the electrical electrostatic hazard, what we were talking about, like where I was telling about the covering this portion. So the potential difference, if the charges are widely spreaded, then what will happen? The potential will be high. Whereas if the space is narrow, then what will happen? The potential will be less. Like for an example, easy to understand, for easy to understand, you can you can think about the pilot burner of the boiler. You have two electrode. If it is two, there's distance to be maintained. Otherwise, what happen if it is too close, then there will be spark, but the energy will not be high. That will not be sufficient to basically to ignite. And whereas if the it is at a particular distance, then you have the energy released because of the electron transfer. It will be high, which will support the ignition. So if the difference of material is very close one another, it is no hazard. And if it is not separated, definitely there is no hazard. But once it is separated, if it is too close, then the charges separation will be low and no hazard exists. But large voltage difference develops when the charge separation is large. Then the large uh, energy is released, which causes the uh, ignition. So the charges, that's why the charges are separated, then large voltage difference is created, and it can uh, have a spark. And charges of the petroleum, like charged petroleum liquid in the tank, suppose it is a static accumulator. A static accumulator means if the conductivity is less, then the charges gets accumulated. Then it's called the static accumulator, electrostatic accumulator, and there are many petroleum product which is static with the electrostatic accumulator there, and that is the dangerous thing. If it gets discharged, then there will not be accumulation. Then there will be less hazard. So water mist formed by the tank also is charged. So these all are the means they can accumulate charge and they can have statical electricity. So suppose uncharged conductor is present in an electrostatic field, then what will happen? This is already been covered. Yeah. So then the once you have introduced, then it will have the same charge. It will be because or the charge will be transferred, and then that will carry the charge. Now the relaxation process of, yeah, it was covered from here. Let us start the process of charge relaxation. What is the charge relaxation? Relaxation means is once the charge is accumulated, then it will take some time to discharge. And how much time it takes to discharge, that is the charge relaxation. It means if the conductor is bad conductor of electricity, it will take more time. If it is good conductor of electricity, it will take less time. So that the relaxation time is important to us so that the charge gets discharged. So high conductivity, the recommendation of charges is very rapid, and because quickly it gets discharged, and no static electricity accumulates in that because the conductivity is high. And highly conductive material, that is only retain or accumulate charges if it is insulated. If the material is insulated, then because it cannot release, in that case, it will be uh, like the retain or accumulated the electricity, that statical electricity. And rate of loss of charges, it depends upon the relaxation time. Relaxation time is high, it means the rate of charge released is less. So another factor, it is suppose a conductor is surrounded, means it's surrounded by the other conductor which is having a different conductivity. Then the relaxation time will depend on that conductivity, which is suppose it is poor conductivity. then the relaxation time will be high. So highly conductive material also can retain charge if it is insulated by the pore conductor. Electrical breakdown. What is electrical breakdown? Between 2 points. It gives, if there is a breakdown of electricity, it means electricity will pass through. So it means it will jump from one to another. So that is the spark it gives. And field strength of 3000 kV, you can see 3000 kV per meter is sufficient to cause the breakdown of air or petroleum gases. So the spark will be very high. Now suppose there is a protrusion like the projection. Then what will happen? So suppose there is a conductor which has got projected. So the field will be accumulated here. The electricity will be very high. So because this density of the means the charges will be very high. Whereas suppose it is like this, the density of the charges will be spread. So that is, and then what happens if the charges are very high, then it gets discharged from this, and the spark is created. So single electrode discharge also you can have that lead to an explosion on the tanker. So single electrode means it is like this one I am talking about. If you have two electrode, two material, you can have the charges flowing through this. But single electrode charges will be very high because it gets accumulated at this point and then it creates the spark. So it's not that the it will be two electrode you will be needing or the two metal will be needing. So two electrode, suppose highly conducted, this means highly charged non-conductive. It means it is charged because of the non-conductivity. It cannot really release. So then if the blunt conductor, it means uh, the blunt conductor will be more rapid than the single electrode discharge. Means in that case, the release more energy, it will release more energy. And two electrode discharge, it ignites gases and the vapor, and two electrode discharge. Let us see what are the two electrode discharge, like sampling apparatus. What is the sampling apparatus? Sampling apparatus means uh, this is a can. So this is with the rope. You put it through the sampling pipe and then you take the sample of all. So this is the sampling apparatus. When you lower, then what will happen? Surface of the charged petroleum, that is the petroleum, suppose it is charged. When it touches, then this is neutral and it is charge will be transferred to this. So then when you are removing it, you have put it through the pipe. Once it is removing it, then the charge, it will carry the charge, and once it touches the metal, then there will be a spark. So fixed tank washing machine also same thing, because you have the tank top here, you have the washing machine, so which is having the, this is projected out, so the charges will be accumulated here. So that is also same problem we'll be having. So a charge gets accumulated at this point. Suppose this is a portable washing machine or the portable. Then when you remove that, this will touch to the hull and there will be a spark. Liquid also can be non-conductor. That's why the uh, static accumulator, they are non-conductor. So it gets accumulated. Solid also it can have non-conductor, uh, and intermediate liquid or the solid non-conductor. If they are, then energy can be released. Instantaneous energy can be released between two conductors. It can be liquid and non-conductors, liquid, solid and non-conductors, and intermediate liquid, that is the mixed. It is not neither liquid, neither like certain cargoes, they are not liquid, it is intermediate liquid. And then solid non-conductor when it touches, and then there can be release of energy. So release of energy instantaneously, you get spark, and that can cause the your uh, spark, which can ignite the, if it is sufficient energy, heat energy, it can ignite the flammable mixture. So the spark, where you can have the spark, unearthed conductive object floating on the surface of the charged liquid. It means when you are putting this can I had drawn for the sampling, the rope what you are using, that should be conductive. That should not be non-conductive. Suppose you nylon rope you tie and put it. That is non-conductive. So you need to use the metal rope, and then the other end has to be earthed on the, so that there will not be any accumulation. Whatever the charge will be transferred to that, it will get earthed. Between unearthed conductive equipment suspended in a tank. That's why it has to be equipment which you are loading into the tank should be earthed. Conductive tools or material left behind the after maintenance. Suppose the maintenance is done in the tank and some conductive tools is kept there. Then what will happen? If some conductive material is being kept there, then there will be, because it will be surrounded by the oil, which is static accumulator, and that charge, because that has been conductive material, it will take the charge, but it cannot release. It will remain, and the potential will become very high. And especially if it is wrapped with the rags or the piece of lagging cloths, then charge will not be discharged, and that will be a static accumulator, high potential. So the spark, it will create spark. And discharge gap, that's, as I told you, that I had given you an example of the pilot burner electrode. It is saying the gap is short enough so that the voltage difference presence is not, means the, it is short, so resulting in flame by quenching. It means there will be spark, but it gets quenched. Quenched means it extinguishes. So minimum amount of energy you need for the combustion. That gap, if gap is sufficient to release the energy which can support the combustion, then there will be a ignition. So this is one thing. Suppose what you are doing is water washing. If you do, this is the water washing. If you see that this is water is falling into that, then it become droplets because of the surface tension, and this height is there. So what will happen once it is splashing also, then it will have the electrostatic charges. So this distance should be less, so that the splashing effect will be less, the static charges will be less. Then steam jet. Steam jet also, because steam, when it is you are introducing into this, then it will create, because of the rubbing effects between the two uh, gases, different gases, and then there can be static charges. This will get charged with positive, because this will give negative charge to the electron to the others. charge missed. So oil, when you are filling the oil, what will happen? This, because of this flow, there will be a rubbing effect, and then there will be charge mist will be created. This is the charge. The mist also will be when your water is falling into this oil layer, because when you are washing, what will happen? Bottom there will be water, on top oil will be floating. And once you are washing, that water will come and hit this, and then there will be a rubbing effect, and it will create a static electricity. This is the tank cleaning machine. If you are cleaning the tank, and if the water hose is very close to the tank cleaning machine, then what will happen? This water will, like this steam jet, the steam will hit the your uh, tank washing machine, and because of the rubbing effect, there will be a static electricity. And where it will get accumulated, you can see this is the particulars, this is projected, this is the nozzle for the your uh, it is a reaction turbine nozzle. So at the nozzle tips, the charges will be accumulated. So this, then it will get discharged, because this will become a single electrode, and it will keep on getting accumulated, and then it will get discharged, and the spark will be created, and there will be a fire. This charged oil also, charged oil means it is having the static electricity. Once it is having the static electricity, then you have the metal at the surface, all around metal. So that will create a spark, because this charged oil and the your surface, there will be a rubbing effect, and there will be the charge will try to discharge, and then there will be a spark, and that can cause the fire. So this is the metal alleged tape. Once you are introducing, what will happen? This is does not have charge, and this oil is charged. Once it touches, then there will be a spark, because the electron will transfer there. Once you lowering it, the metal alleged tape, what will happen? All the charges will come. When it just touches the surface, there will be a spark, because there is a potential difference. After that, what will happen? Once you are lowering, this will get charged, because all the charge will, electron will come and transfer to this metal tape. Then what will happen? Then once you are removing it, this, because this is unearthed, so what will happen? There will be a charge here, because you are standing here. So that's why when you are standing, you should be wearing the safety shoes, so that the charge will not get transferred. And it will be, there will be a spark here, because once you have lowered, first spark will be here. After that, the spark will be here. Once, because there is no gap now. So the transfer of electron will be there, and it will get released through this. It will get discharged through this, and there will be a spark here. And there will be an explosion of the fire if the spark is sufficient. Metal can, that is the sampling can, is the same thing. Suppose you have used the hemp rope, that is the, this is non-conducting rope. So there will be a spark here, because you are, it has, once it touches, it cannot discharge, so there will be a spark. So liquid are considered to be non-conductors. That is the reason it is static accumulator. So conductivity is less than 50 picosiemens per meter. So this liquid referred to be static accumulator. Those are dangerous, because the static charges cannot be discharged. So petroleum product, the conductivity can be below 10 picosiemens per meter. Chemical solvent, it is highly refined fuel can have conductivity 1 picosiemens per meter. It means they all are non-conductor and the static accumulator. So the electrostatic hazard. So what is been done? Those the oil which is static accumulator. So we use additives. So anti-static additives has been added. And once anti-static additive is been added, then it become the uh, non-accumulator. It does not accumulate the electricity. It can be discharged. So it becomes safe. But one thing, this anti-static additives, it has got an expiry date. So it depends when it was added. That's why when the cargo information comes, it has been given to the vessel that when the additive was added. It may be added, but it is expired. Or it may be added, it is not yet expired, but before it going to be discharged, it may be on the at sea, it may be expired. Then it has got no effect. It means you'll have to take additional precautions. So that is though it is the additive has been added, but within expiry date it will work. So the expiry date is very, very important. The effectiveness of anti-static additives, that's why length of time the additive was introduced to the product. So, and the satisfactory product mixing. It means if it is a homogeneous mixing has been done, then it will be more effective. So, if once actually you use the additives, then the conductivity increases. And conductivity should be more than 50 picosiemens per meter. Oxygen deficiency is another problem which is very dangerous health hazard. Oxygen deficiency, the oxygen contained in air is 21%, and it in enclosed space it become lower. Now, uh, it depends upon the person to person, it varies the susceptibility of the oxygen deficiency because everybody does not consume the same amount of oxygen when he breathes. So, oxygen content drops below 16%, then all will suffer, whether a strong or a weak person. And oxygen is less than 21% in atmosphere, extremely dangerous. In an atmosphere, it has to be 21%. And because why it is less than 21%? Because there are some other gases which is replaced the oxygen. That is the problem. So this is the oxygen deficiency. You have asphyxia because of the oxygen deficiency. So lack of oxygen, what has been done, what is always you must suspect that there is lack of oxygen in enclosed space. Never guess that it may be 21%. No, you always consider that it is less than 21%. And especially if a ballast tank, for an example, partially filled with water, then what will happen? As I told you, there is humidity and there will be oxidation, oxygen will be consumed, and there will be lack of oxygen, deficiency of oxygen. And you, if anybody entering into that space, will have the asphyxia and he will collapse and you lose his life. So amount of oxygen is decreases below 21% by volume, which is normal, 21%. Then what will be the symptom? The symptom in the deficient atmosphere, means the oxygen, deficient oxygen atmosphere. So it is a danger to the human health. So what will happen that as we know that below 16% everybody will be affected and everybody nobody will be able to survive in that atmosphere. So this is if you see this, the 23%, this is normal safe oxygen level is 19 to 23%. Less than is green, and then 16% fast breathing, increased heart rate, drowsiness, nausea. And then 12% person become unconscious. 6% once unconscious, after that death. So that's why whenever you are entering into an enclosed space, you must ensure that oxygen percentage is 21% and 21% or 20.8, 20.9. And also high oxygen level also is bad for us. 25% increase fire risk, 100% brain death. This from 25 to 100 is brain death occurs. So whenever you find that you are a normal person, you are entering into a space, enclosed space, and your breathing has become faster. It means there is oxygen deficiency. That is the symptom, first symptom. And what will happen that many people unable to understand, unable to recognize that there is a fail of danger, there is a danger. Then they become weak. After that, they realize. And once they become weak because of the deficiency of oxygen, then it is too late. What a person will do in that case, he will try to come out. Once he is trying to come out, then he will exhaust his energy more. And once that happens, and our tanks and all, enclosed space, it's not easy. There are vertical ladder, there are rung ladder. So your exhaustion is high. Once exhaustion means climbing up, it will cause the exhaustion, and finally the person will collapse. That is the problem. That's why never ever enter into a space where you have the oxygen deficiency.